move on with life. Okay, that's my job. And teach you a little something along the way. All right. Type 3, story. I'm lying a little bit. It might change later on, but just a little white lie, right? You will be provided with 2 points, and you have to find the third point using symmetry. So for now, we're going to focus on that a little bit. The best way to solve this type is to sketch it first. I would say sketch it first, see what's happening. Are you starting on the ground? Are you starting off the ground? What's happening here? Remember that the third point, I'm going to use the same color for the third point here. The third point will be across the starting point. That is important to remember. So I have scenario 1. Scenario 1 is when the starting point and the vertex is given. The most popular here, I'll say most popular. Most popular scenario. Scenario 1, most popular. The vertex and a starting point is given to you. So, on the ground scenario. So imagine a ball is kicked and reaches a maximum height of 17 feet after 1.25 seconds. Okay, so we're assuming that obviously the ball is going to be right here. That's where we start on the ground, and it goes up, reaches the highest point, comes back down. Already we know that this is time and this is height, so no questions there. So the first point is 0, 0. Do not underestimate the power of 0, 0. Okay, some students are like, I need another point, right? 0, 0 is our starting point here. What would be this one right here? Do we know the vertex in this point at this stage? And we do, because it says the maximum. It doesn't just say any height. It says the maximum height is at 1.25 seconds. So this is the vertex. The vertex is 1.25 because it's x is always our first entry, which is time, 17. Okay? So we're going to copy that onto our little sketch. Please do, I would say sketch every time. So, and now I want you to think of symmetry. Symmetry right here. So I'm going to tell you that the vertex, as you recall, splits our parabola in half, right? There's that axis of symmetry. So there's a couple of ways you can handle this. You can say that from my starting point to the center is how many units along the x-axis? 1.25, right? It takes 1.25 seconds to get to the middle along the x-axis. How many units is it going to take to get back to the same height as my starting point? It's going to be another 1.25. Does that make sense? Okay. So that means that this point right here, that one, will have a height of 0, same as what I started with. And this will be 2.5 in this case. So, but I don't want you to just think of it that way. Absolutely, it's probably the fastest. It's probably the fastest way. But do you remember, I don't know if I'm going to fit that in here. I'm just going to explain it. Do you remember this one? That's, I'm just going to, axis of symmetry, AOS. Maybe just write it down to remind you. AOS is x is equal to x1 plus x2. And what else? Divided by 2. Do you remember that formula? I hope you have that on your study sheet somewhere. So technically, for this formula, we have x, we have x1, we're solving for x2, okay? So you can use that, you can always use this to help you out if you're not sure what to do here. I find it easier to just think of it, oh, symmetry, 1.25, another 1.25. you're essentially taking that and doubling it to put it in there. Okay? It's okay to do it like we can go arrow and we just go times 2 in this case. It absolutely works. Nothing wrong there. This is my third point. I hope this isn't gonna ruin my... It's okay, right? But that's like the grandiose third point that I'm talking about. That's the one you need to complete. Because how many points do we need for a regression? 3, right? So 1, 2, 3, done. All right. And then so we take this sketch and we go time and height. This doesn't need to be super, elegant, but you just write these down. 0, 0, 1.25, 17. That's my vertex, by the way. And then you go back to 2.50, 0. And I think it's worth highlighting that we start at a height of 0, right? And then we end back at 0. So these 2 points are looking straight at each other, okay? The start and the end they can look right at each other across the field there, basically. Okay, let's do another one. This one over here. I already sketched it for you. Maybe I shouldn't have. But an object is thrown from a height of 8 meters, reaches a maximum height of 13 meters at a distance of 3.5. Now we're talking distance, height. Distance is horizontal, right? Height is vertical. But this right here is your vertex, right here. My vertex is given to me because it says the word maximum. And that is what? You got to make sure you don't mix it up. 3.5, 13. That is the vertex. And what is this? Thrown from a height of 8 meters. What would you call that? Y-intercept, 0.8. Would that make sense? So we can put those down. 0.8, so you're not on the ground, you're off the ground. You reach 3.5, 13. And here's the biggest temptation. Guess where students find the third point? Where do you think they go across? No. Most students go straight back to the ground because, hey, it's going to land there somewhere. So that's my third point, right? And I'm saying, no, it's not the third point. The third point is always across where you started. Okay, so we're going to go with a line straight across, arrowhead if you can. This is the third point in this case. So we're just focusing on that cap here. Okay? What do you think the height is going to be at this point? Same as where I started. So I'm back to 8. I'm back to 8. And what is my x value going to be at this point? It takes me, let's do this again here. Let's make our axis of symmetry. It takes me 3.5 to get to the highest point. So guess what? It's going to take me another 3.5 to get back down. So we're at a total of, I used nice round numbers, okay? But it won't always be. You will have decimals, right? So you can take the x value of the vertex and multiply it by 2 if you like to get that. So that's my third point. That is the key that unlocks this whole thing. So we go distance and height in our chart. We go 0, 8, 3.5, 13. Then we go 7, 8. This was a good opportunity to do a 6, 7, right? But next time. 7, 8. So guess what? You start at a height of 8, we come back to the height of 8. So that's important there for you to remember. Maybe as you review, you might appreciate this third point. Always I'm not going to say use the word always, because then you might say, hey, you said, right? Third point across starting point. Across the start. I'm just going to make that little note there. Okay. Because sometimes the question is just going to flat out give you all 3 points. No need to come up with a third one. But if you are stuck with 2, you need to use this property to figure out the third one. Okay? We're good? So this is one of the scenarios. The other one is where the vertex is not provided, at least not fully. So make sure you write this down, and then we're going to go with that. And okay, let's go to scenario 2. No vertex provided. Okay, there's no vertex provided. So still on the ground, off the ground, we're still dealing with the same situation here. And remember, symmetry is always there. Okay, so here an object is thrown upwards, reaches a maximum height of 40. Maximum height of 40. So you might think, hey, the vertex is there, and lands and remains airborne for 8 seconds. So what's happening here? Well, we're on the ground. Okay, so we're assuming 0, 0 is there. This thing stays airborne for 8 seconds, right? So it lands after 8 seconds. So we know this one is 8, 0. And do we know the vertex fully? We don't. We know that the maximum height is 40, which tells me that's the y value of the vertex. I know that, but I don't know this part. Guess what? We're still using axis of symmetry here. Just when you thought you don't have to use that word ever again. So what are we thinking here? It's 8 from start to finish, right? So we're going to split that exactly in half, right? So we're assuming it takes 4 to get to the middle, and it takes another 4 to get to the end. So therefore, this has to be, I'm going to use a red pen for this. This has to be 4 in this case. So you essentially take the total flight time and just divide it by 2. And you get your middle. This does not work if you have a point somewhere here, right? Then it's not 4 from here to there, but it is 4 from here to the end, right? Because we're along the x-axis here, and these 2 points are right across from each other. So let's fill this in real quick. Time and height, 0, 0, 4, 40, and 8, 0. Does it matter in which order you put these points in? No. But if you crisscross, then you're in trouble. Like if you match 0 with 40 and 44 with 0, then you're in trouble, okay? Then the calculator is going to complain. Let's do another one here. A skier goes down a 30-foot ramp. That, I mean, is this point right here. We're at 30 feet at the beginning when we're going down the ramp. The lowest height is 12. Okay, the lowest height is 12 feet and reaches the initial height at a distance of 50 feet. This is a little tight, just letting you know. I'm not too proud of this graph. But what we're basically told is that if we were to go across the starting point right over to this end here, this point right there, okay, we know that we return at that same height that we were in at the beginning, at a distance of 50 feet horizontally, we get back to 30 feet, back to our height. So we slide down the ramp and then come back up 50 feet later, initial there. This is going to get a little crazy here. I'm going to go arrow to that point, and I'm just going to say that our lowest height is 12 feet. And we use our axis of symmetry again. Split that thing in half. If this is 50, then this would have to be 25 and 25, right? So we know that from the start of our journey to get to the lowest point is going to be 25 feet. So basically, guys, you did the opposite of what you did in scenario 1. Instead of multiplying by 2, you kept on dividing by 2. Okay? So this is distance and height. We've got 0, 30. We've got 25, 12. And we've got 50, 30. There you go. So all of this just to come up with those 3 points. It's going to be a lot faster, trust me. You're going to do this very quickly down the road. So I'm going to skip page 72, and I'm just going to focus on, can you come up with the 3 points right now? And with the 3 points, that's it for now. So let's go to 73. And right now, make sure you use a pencil. I want you to have a little sketch here somewhere, and I want you to come up with the 3 points that go into this table. Do not continue your journey yet. Then you go to 74. Read that question, make a little sketch, fill in these 3 points. Okay? Then you go to 75. What's 75? What kind of a regression is that? That's type 0. Don't even worry about the types. Just know, oh, points are all given. I just need to put that into L1 and L2 and solve. Okay, that's only if you get there. For now, don't worry about that. I want you to try 73, 74. Just come up with the points. Read the question, make your sketch, come up with the points, and then you do the same thing for 74. Make sure you use a pencil, because if you make a mistake, we can make a correction to those. Okay. So go ahead, try that right now. Let's just make sure we all have the same points, and then you can continue working. So on page 73, right, this is time and this is height, and it only needs to be a sketch. You're kicked from 3 feet off the ground, so it's somewhere off the ground, reaches a maximum height, we have that coordinate, and then eventually, I guess it will land on the ground, right? So 0, 3 is your start. 2.9 seconds, 34 feet is your vertex. And then remember, you want to go across, right? So you're going to be back at 3, and it takes you another 2.9 to get there. So we're going to go times 2. So this is 5.8. 5.83 is the way you do that one. Okay, so put that in here. 0, 3, 2.9, 34, 5.8, back to 3. This is part of your work to determine the equation, guys. All of this is part of the work. I want you to type this into L1. This goes into L2. Then we're going to go stat, calc, quadratic regression. Let's go ahead and do that real quick. Let's do that real quick. Stat. I wish I had your typing skills, guys. You just beat me to it probably every single time. Okay, so I've got my points. I check, I make sure. You can go and clear all the equations, do a zoom stat. Zoom stat actually works great here. It shows you the 3 points on your grid. I'm going to go to my home screen, and I did quadratic regression not too long ago. So I'm going to select that, hit enter again, and that's my equation. That's negative 3.669 x squared plus 21.38 x plus 3. And there you have it. I hit graph. I see that it actually touches all 3 points. Guys, once you have this equation, it's basically back to what we've been doing all along with word problems, right? I gave you the equation. You just have to do the extra work to come up with the equation, right? But really, once you have it, it's back to everything we've been doing so far. So how long does it take for the ball to hit the ground? What are you finding here? You're finding that x-intercept. Okay, so I'm just gonna, I would ask you to copy this. I want to have one example where at least you have all the answers. Second trace intersect. And that intersection ends up being 5.940, but please don't just leave it like that. You need to go 5.94 seconds. Bless you. 5.94 seconds. What do we do for question D? Determine the height of the ball after 4 seconds. You're still busy copying. Don't ask me questions, right? What do we do here? If you struggle with this, ask yourself, what do they give me here? Time or height? They give me the time, so they must be asking me for the height, right? So when you have this, you got to use second, trace, value, x is equal to 4. Okay? So I'm going to use that on my screen. I don't need to change the window here, okay guys? Did you notice that? My window settings are perfect here. Second trace, value, x is equal to 4, and there it is, 29.54 feet. This is where, for the most part, unless you butcher it pretty bad, let's say you get your equation wrong, you lose a mark, but then everything else, when you answer it based on your equation, it's a nightmare for me, but you still get the marks thereafter. The only thing that I will say this is if your answer cannot be, it just doesn't make sense. Like I ask you something, you're like, wait a minute, my parabola is pointing up. What's going on here? That's when I draw the line and be like, no, we're going to take more marks off, okay? So, what else do I know already? I know this x-intercept here, right? I would like you to, for domain and range, guys, I like to have everything that I need on it. So this is 2.934. This is 0.3. This is 5.940. I found that x-intercept. So what is my domain? Domain is your x values, right? Goes, it stops at 5.94. So my domain goes from 0 to 5.94. My range goes from 0, it does land on the ground, right, all the way up to the highest y value, which is determined by the vertex in this case. So you go from 0 all the way to 34 feet. Okay, so that's your domain and range, a review of that. How long does the ball stay at or above 10 feet? What do you think is going to happen here? This is a delta t situation where you have to figure out both of the instances that it happens. Let's go to this. Slow down, Mr. Dirksen. I'm still copying. Okay, fine. Catch up to me here. I can't go too slow because then we just won't cover everything. But I also can't go too fast because then I'm losing you guys, right? Where's the 10 mark? At or above 10? It's some. If this is 3 for me, right about, let's say this is the 10 mark right here. Okay. So there's a starting point where it starts at 10 feet and then it keeps above it, goes back to 10, right? So let's figure out those two times. Time 1 and time 2. page 73. Y2 is equal to 10. Hit graph. There it is. I'm going to figure out both of those instances. Enter, enter, enter. The first one is 0.3483. The second one, I'm going to skip. Yeah, enter, enter, enter. That one is 5.4517. I'll just give you the answer. That's 5.10 seconds. And my favorite, graphing. It should be your favorite too after a while. Hopefully you know exactly what to do when it's graphing time. Okay. Time in seconds, height in feet. Get that out of the way, guys. Just do that right away. Boom. How about we do our equation right away? I think if I put it out here, we're safe. Okay, for me. Thank you. 73. So my scale, right? I look at my x values. What's the highest number I ever get to in this story? Almost 6. Almost 6. Not quite. So we're going to go 5.94. So let's see here. 1, 2, 3, 4. Oh, that doesn't really work. Going up by 1. So I'm going to go 2, 4, 6, 8, and so forth. That's going to work for me. And this way, what's the highest I ever reach? It's 34. So 10, 20, 30, 40, that'll do the trick. Zero 3 is right about there. 5.94. This is 5. 5.94 is right about there. And the highest point is 2.934, right? 2.9, that's almost 3. This is 35, 34 is right there. So just over there, put your point down. Beautiful, right? You've got everything you need on that graph, okay? So I'm just going to say this. Everything, page 72 to 76. I'm going to go 75 for now. 76 has a QR code. Guess what that QR code is going to take you to? It actually is a video of me solving that one. So if you need another example, 76 is maybe one you can scan and see, like, I need another go at this. I need another example where you walk through it step by step. That's what I'm going to do. So 72 is the one before this. It's a little tricky. So I'll say for now do 74. If 74 goes well for you, then do 75. And then maybe go back to 72 and do everything else that is still pending. Okay? Make sure you try